everybody, welcome back to the NESGameMaker. Today we are going to be working on building the link object and some other things. So let's get cracking. Last time we left off with the room North Palace. You can see over here in our project, rooms North Palace. Currently just have a nice purple background. So we want to turn that into an actual room at this point. Though, of course, we won't have everything that's in here. So let's get adding some stuff here. We need a layer. I'm going to call it menus. And this is some effects, tiles, and some background assets. All right, so let's order that properly. All the instances go up here. You go background underscore assets, collisions, background. We're going to change this to a black ground because we need the black. Let's see. So we got 1, 2, 3 instances. Goes right there. You become menus, because that'll be where we show the menu when the player presses the pause button. Effects, because we want effects to be behind the player so they don't block out your view of the player. And enemies, because we want the effects to be in front of the enemies, but behind the player. I could have made a layer called it player as well, but I didn't do that way. For the instances layer, let's make it an 8x8 grid to make it easier to place the player when we get to making him. For the background asset, also make that an 8x8 layer, and we are going to want to drag in a couple of different assets. We have here our sprites, backgrounds. No, not in there, though it should be. North Palace. I gave it its own folder here. So we want you right there with 4 spaces above it. So that'd be 32 pixels total. And we also want these tall torches. Drag them over to there because we want them to just animate in the background. And before we do anything, make sure this is at 10 pixels per 10 frames per second to get the appropriate flickering action. If you come over here and okay, there it is, hit the play, you can actually see it in action. So that also works for tiles too if you have animated tiles. So that's something useful to know about. Collisions. You'll note that in this project, the project assets, I have included a abbreviated version of my full collision code, which mainly covers, in this case, just tiles, because that's what we're going to be using. So go down here, just tile collisions, back to there, grab out the tiles, and on the collision layer, well, we can actually drag this up a little bit so that we can see and just draw in some collision tiles to have the floor. And you can draw some other tiles if you feel like it, like a little thing like that for you to jump over, and have a little platform here if you want to test platforms. Ladders also kind of work, but they require building a state to be able to take advantage of them other than just being able to walk on them like a platform. So we don't build that into Link because Link doesn't use ladders, so you can kind of ignore the ladder. In fact, I don't think he even uses platforms in this game. He might. I just don't remember if he does. So yeah, it's basically not needed for our purposes in this tutorial. Let's see, enemies lairs. There shouldn't be anything there because we don't have any enemies in this room. Well, we'll throw some of these onto a test later on. And we have the menus over here, nothing on there as well. The only thing we want to build now is the link object. So let's come over here to our objects. We're going to create a new group and call it link. And inside there, create an object. G underscore link underscore side scrolling. Or put a space right there. And for good measure, come into the sprites, link, and give him a sprite to help you see what he looks like. Doesn't matter what he looks like, just so that you can get him in there. We're going to drag him into the room and put him down here. So you'll note that his feet go 1 pixel into the ground. And that's pretty standard in a lot of NES games. The feet will always go 1 pixel into the ground. And that would be because if we come over here to our link sprites, the collision mask has been set up to be 1 pixel higher than Link's feet, and his origin point is exactly at the bottom of the middle, I should say, of the collision box. So that makes it so when you place him, he gets placed with 1 pixel down, but his collision box is actually right on top of the ground. So that lets him move around properly. All right, so what we got here? We're going to need a lot of stuff to get Link working here. So, as I mentioned earlier, he's the most complicated object in the game. Well, there's also the overworld version of him, but he's not going to be used nearly as much as this version. So let me pull up in the create event and some other events. So let's add in a create event, a step event, a draw event, a draw GUI event, and then we'll have a whole bunch of user events, but for the moment we'll just have user event 0, which will be the move state. And let's come over here. I'm going to try to keep this simplified and build on it as we go, but you know, it's kind of going to be difficult as we go through this. So let's start off with a region. Code snippets, region. This would be camera. And we are going to put in the code here. Object camera.state is camo.targeted, and object camera.state is equal to target is equal to ID. So what this does is once the link object is created, which he's created as soon as the room starts, the camera is targeted towards him and told to follow him. That's fairly simple. You could override it if you had need to for various things, but I believe this works pretty well for the way the game is set up. So we're also going to do something interesting here. So with methods. So earlier, remember I was telling you about how we can set up the methods for code that we repeat a lot. In this case, I have this code fragment called change state because we do a lot of different things when we change state. Namely, we set the frames currently in state to 0, we set the previous state to the current state, and we set the current state to the new state, which is a value you pass in. And we set the sprite index equal to the sprite that should be used for the new state, the image speed to 0, because we'll edit the image speed in the animation section of each section. And before I forget, let's increase the text size for our visually challenged friends. And our image index to 0 because we want to start on the 0 frame of each state, because we do not have blend systems in our states here. Like if you were to say do something with spine, you could actually have Spine has blending capability that allows you to blend the animations between the states, so it looks like somewhat seamless transitioning between them. But in this case, we're just starting at the 0 frame when we transition between each state. So this will be very useful. We're going to use it in every single method, and so I encapsulated it to make it easy to bring along. Now we're going to have the Enums section. Enums player states. So in this case, you can call the enums whatever you want, but in this case, I called it player states. We have move, jump, duck, duck and slash, standing slash, find treasure, which won't be used in this tutorial because we don't find treasure. Well, or do we? No, we don't. So, well, actually, I did set up the finding treasure state as a for the Patreon thing, didn't I? So I might include that as well. Then damaged, when you take damage, then landing and jumping slash. So jumping slash should actually be over here instead of all the way down here at 8. But that's apparently the way I had it set up for whatever reason. So anyways, as far as it goes, I call this player states, and then, you know, I have the link side scrolling over land, so I call that player overworld states. And then you have enemies, so I would call each the moblin states and the spider states and the bat states, etc. So giving each enemy and player object their own unique set of states. So now we're going to have a couple regions here. Code snippets region. Let's see, we're going to need 1, 2, 3, and 4 of these. And we're going to call this one animation. And this one over here, move variables. This one here is going to be Sprite look up table. And last but not least, the room starting position. Though we won't get around to that one for a while because you don't need it right now. So animation wise, you probably remember a lot of this stuff if you followed the Chippendale tutorial, and yeah, that's a lot of it. It's very similar, but at the same time, it's kind of a moving target. Just building all this stuff, I'm constantly fiddling with and changing how things are set up. So in this case, we have a bunch of different stuff like image speed equal to 0 because we don't want to be animating. We'll handle that in the states. Image X scale is equal to -1 because actually all of our sprites are facing right, and we're going to be using X flipping to flip our player sprite around. So we'll flip between 1 and -1 for the X scale. So we have them facing left to start with because faces left to start because that's the way it was in game. There we go. Animation speed is equal to 1 because if we come down here to our sprites, let's see if we can find one with a very good animation. Where's Link Walk? There you are. We have set up the FPS in the sprites to be at 1, so an animation speed of 1 would give us full speed animation. Then we need a target direction. Dirt 8.left, if you remember right, Dir 8 is over in our defaults setup script. And we also are going to have a facing direction. And this could also be Dir 8. It doesn't matter, but I use Dir 4 for this setup. So what we got here is our target direction. So the player can aim in 8 positions. So like in Mega Man tutorial, you can aim at diagonals, but Link can only face left or right. So, and I actually had a Dir 2, but I figured that was just kind of redundant. So I figured, okay, I'll just use Dir 4. And then I figured, okay, well, if Dir 2 is redundant, then I could probably just use Dir 8 for everything. And, well, that's, like I said, moving target. I'm constantly changing and fiddling with things. So, as mentioned, state and previous state. Set us to the move state to start with, because that's where you start in, which will actually also be the idle state, because when you're not pressing anything, you just stand there. Then we have some iframes and flashing stuff, which will be set up later on, but here it is for now. The player iframes, so when you take damage, this is how long your iframes will last. So we have iframes false, iframes length, floor sec times 2, and iframe timer -1. We also have flashing length and flashing timer, because you flash for longer than your iframes. So while you have iframes, Link does this color palette shift thing set up. But then once his iframes are over, he continues to flash for like another. He continues to flash for a slightly longer period of time, which I'm using in the iframes. So these are kind of misnamed. The flashing length is more like the iframes length, and so on and so forth. So yeah. Anyways, we'll get around to them when we get to drawing and stuff. So let's see. Oh yeah, we also need this damage flash speed. It's how many frames between each flashing setup. Then we have manual sprite change, which we use quite often over here in our animation stuff. We'll actually move it right over there just for consistency. And let's see, frames in state. There we go. Frames in state, 0. Palette sprite is sprite palette link. So I've set up all these palettes down over here. So we have Bitbot, Dealers, Link, Moblins, and Moblins. So they all have different color palettes they swap through whenever they take damage. So we have that information right here. And palette index 0, which is to say that's what the normal color is. Then last but not least, we have this one, damage facing direction. So when Link takes damage, he faces towards the source of his damage while getting knocked back. So this basically tells Link to face towards his source of damage. And last but not least, visible underscore is equal to true. Because Link needs to be visible. Alright, so I'm just going to dump all these things into here because movement variables take a while to look through and all that fun stuff. Movement, X fraction, Y fraction, X input, Y input, etc. Ground acceleration, air acceleration. We have multiple different acceleration types, so you can actually change your acceleration depending on your state. Ground friction, air friction, again, changing your friction based on your state, plus gravity. And speeds, we have the jump speed, the walk speed, the air speed, so you can have maximum speeds that they can go. And fall speed, which I ended up not using for some reason, but I'll try to live edit it in during the tutorial. Our current X speed, our current Y speed, our X speed previous, our Y speed previous, And these were kind of obsoleted because I ended up setting up a new X speed and Y speed system using current X speed and applied X speeds and Y speeds to give us that lerpy sort of left-right movement, which allows you to sort of skid as you get to the when you press left and right. And of course, collisions would be the time up get ID for collisions. That's to be the ones that we set up over here. Then on ground, on wall, and wall to your left or wall to your right. These are used for telling if we're on the ground or if we're up against a wall. And if we're up against a wall, then is the wall on our left or is the wall on our right? So we use these to tell player to stop animating when he's walking against a wall, which technically they didn't do in the original game, but I think it looks much better to do it that way. So, all right, Sprite lookup table. We're gonna bring all this stuff in as well, copy and paste because it's just a bunch of copy paste stuff. So we have the move state. We remember we have a sprite variable, which is a 2D array using the player state and the player's direction to look up what sprite should be displayed when the player is looking in certain directions. So we have sprite link walk when they're in the move state, and no one for when there is no sprite change to be done. So keep that in mind. You need to have that no one there. Same for jump. Make sure you change this to jump. Then you have duck, and of course you have ducks, and landing. You have the duck because there's a landing state, and you do a little duck thing when you land, and then you get up and keep moving, kind of like a Batman in the Batman NES game. Duck and slash, etc., etc., etc. So there we go. And last but not least, let's see here. Room starting position. All right. So I guess I can put this in here and it wouldn't be too confusing. So if you remember correctly, if we come back over here to our not room objects, menu objects, we have save create. We have this big, huge save file with all sorts of information about us, specifically some information about what direction we enter in the room. So in the case of when you start a new game, you start from no one because you are in the room, you were started in the middle of the North Palace room, as you can see here. So to get started with, we have if global.current save data.entry direction is equal to no one, so when we start the game, and you probably want to copy this a little bit because you're going to use it a lot. And else if global.entry direction is equal to dir 4.right, so if we came in from the right side, then we're going to be putting ourselves at the right side of the room. Else if global.current direction is equal to 4.left and put us at the left side of the room. Else, which is basically our default if we have no other option. You know, I could set this up as a switch actually. You know, that probably would have looked nicer or something, but this is the way I did it. So x is equal to room width divided by 2 and y is equal to 208. We come back here to link. No, 208 is y position, and room width divided by 2 is his x position. I could have just put it as 384, but you know. Let's see. Then for you, we're going to also put this in as x is equal to room width minus 8 because we start. Let's see. 8 is half the width of the player's sprite, so you could actually do something like sprite width Divide by 2. Yeah. I think that's right. That's how you use sprite width. Let's see. Then we have for you, it would then just be at right. For width divided by 2. And y equals 208. In all these instances, y is equal to 208 because the y is equal to 2.8. Well, because the floor is at 208 in every single room. And we also want to add in current underscore x underscore speed underscore is equal to -2 because we want to make link do a little shimmy into, well, not shimmy, but we want to walk into the room, so we force a x speed onto the player object to get him started with. So then in this case, so -2 right here, and in this case we also have 2 for you, but we also, since we're coming in from the left, we want to change the animation so Link is no longer facing left when he starts. So we'll want to update all that information. So we have target underscore direction underscore is equal to a dot right, and facing underscore direction underscore is equal to 4 dot right, and last but not least, image underscore x scale is equal to 1. And finally, if something weird happens, just say x is equal to room underscore width divided by 2, and y is equal to 56. Why equal 56? I have no idea. I just set y equal 56. There was probably a good reason for why I did it. Let's see, y equals 56. It's like right up here. I don't know. Probably just something for testing purposes. Oh, I see. It's this is actually top entry. So if a link comes in from the top, in the case of there are certain holes you can fall through, that would then cause you to have like a little that would cause you to fall down into the room below. So in this case, you would start off at y equals 56. And you start off at the center of the room. All right, let's see what our time is. We are currently at 27 minutes and counting. So I think we are done for the time being. Thank you everybody for watching. This has been a great time. And I'll catch you next time on the NESGameMaker. So take it away past me with some Patreon names. I'd like to thank my legacy Patreon sponsors: James Burton, JD Lowe, Sue Lee, and Vazia. I'd also like to thank my current Patreon sponsors: Kenneth Klein and Vladimir. Your support helps the NESGameMaker be made and to continue to grow, and I hope that you all continue to have good luck with your programming.